scientists, physicists and engineers, they are looking for new kinds of energy, new kinds of, and because when we look for new kinds of energy, also the military has to put its hand. So in Italy, also these experiments are done in military laboratories. Here you see Gianni, Albertini and Fabio Cardone. They belong to the group. These two physicists are experimentalists. They have also theoreticists, Roberto Vigier, for example, and why? I have first to explain the title, Deformed Space-Time Reactions. They created a theory to explain the results of their reactions. You know that in general relativity, the presence of mass is the cause of curvature of space-time. They say that also the elementary particles in the neighborhood of the elementary particles, when they are pressed, they begin to exist a deformation of local space-time. Because gravitational interactions are macro and mega phenomena. It is impossible to speak of a gravitational interaction between two neutrons. It is so favorable that it must be negligible. So there are other forces that locally deform the space-time according to this theory. New nuclear reactions, their futures. Nuclear signals without gamma ray emissions. When they press with acoustic waves, for instance, you will see also some images. Then when you use a Geiger-like device, they find out that there are in these reactions come out neutrons or alpha emission. This is the nucleus of this is not the hydrogen. This is the
helium.
Helium, yes. And so that they are not gamma ray emissions. So, and they make also experiments that when they press some other nuclear reactions in which there are gamma radiation are neutralized. So they go in two directions to create a flow of neutrons or alpha radiation, and to neutralize in other reactions the gamma radiation. The second thing is variation of atomic weight of the reacting elements, phenomena characterized by an energy threshold. Phenomena characterized by an energy threshold means that an energy threshold must be overcome at microscopic level in order that reactions occur. At macroscopic level, a critical density of energy in volume and time, it is in space-time, must be overcome in order that phenomena occur. The energy threshold and its corresponding critical space-time density of energy are the boundary that separates flat Pythagorean Euclidean Minkowskian space-time from the form space-time where interaction takes place. In this space, the local Lorentz invariance is broken. The energy density in space-time was varied in a stainless steel brought by varying pressure through ultrasounds, consequences, neutron emission, and formation of holes in the bar. You see here a hole. Here's the bar. Composition of steel matrix and damaged zones of carbon steel rod treated by 19 volts.
Excuse me, Ludwik, could you sit down and we can see the slide and you'll be easier reading it as well. You know, if you just like it was done yesterday by Richard's, you know.
Don't want to sit down?
But you want to sit down while you read your...
Sit down. Oh, okay.
You just got out of your way.
Yeah.
There.
The details of the deformed space-time theory can be found in the books. Fabio Cardone and Albertini-Cardone published the book Deformed Space-Time, Geometrizing Interactions in 4 or 5 Dimensions. Another book written by these two physicists. Gianni, as I say, is a theoretist, Cardone an experimentalist. What is my contribution to this whole affair? I would like to say also that the whole paper concerning the subject of my talk today, I have here 20 copies. If someone would like to take, my contribution is, I presented it in the 2010 Vigier conference. I have here also some copies of this paper, but I would like only to explain what I have to write in the portion. You know the famous equation of Albert Einstein? This equation can be written also in this way, where this is the Kittel's gravitational length. We can also write this equation in such a way, where here's the Kittel's time, gravitational time. Into the Earth. And when we applied this in a Newtonian approximation to the famous Newtonian equation, we can consider them as you know it. You can when you use this equation, write this in such a way, where here's the square of the Kittel's length, and here is the distance between the two masses. When the distance is equal to the gravitational length, then we are dealing with a force that is about 1044 newtons. And when I presented this at a conference and Fabio Cardone was present, then he said we have to press. Because when we can also write the other, the Coulomb force, take us 2 electrons. We can also write this in this way. And here you are the length of stomach, and here's the length, the distance between them. Also here, when we approach 2 particles that are electrically charged, there is a distance called stomach, because he introduced this length. The force, the Coulomb force, is also equal to 10 to 44 newtons. And this causes that they begin to press the matter. Also the Technical University in Torino, there's a professor that finds different kinds of pressure of matter, and when he put a Geiger like a device, they found out neutrons, and so they called this reaction piezo-nuclear reactions. We have already piezoelectric reactions, now there are piezo-nuclear reactions. So they make this kind of reactions, and they have some always more, they make always more experiments. They have already a national center in Viterbo, National Center of Nuclear Reactions, and now they begin to collaborate also with the European Union in these reactions. That's all what I wanted to say, because I'm not so awkward. They created a special metric. This metric can be found in their books. If someone would like to have e-books of these 2 books that you see here, I have them on my pen drive. If someone would have these 2 books, I can give you these books through a pen drive. Thanks for your attention.
Any questions for Ludwik?
What order of magnitude of pressures are involved? Do they have a giant hydraulic press or something that they, or is it small amount? What is the order of the pressure involved?
I am not sure.
It's in the paper.
Because my contribution is on the idea, and that is why they put also my name. Also in their books they quote my papers.
Yeah.
So that is on my
I see.
I am not au courant in the details.
Oh, that's fine.
Maybe the books tell it. You can
Maybe, yeah, mine, yes.
No, go ahead, finish that. Any other questions? Is this, what do you call it, sonar luminance, where you have a liquid, where you put the ultrasound in and you have the little bubbles that glow in it? Would this be the same effect?
Yes, because there's also in Poland, there's Gdańsk is a professor and engineer. he makes the same experiments, not with acoustic waves, but because he works in a center of, how to say, they use cavitation bubbles, but in water. He was astonished that he introduced not many energy, and he receives more than it was at the beginning. And so he arrived also that something with the nuclear in this cavitation, then pull down, the temperature increases, and he has many more energy than at the beginning. So he entered in the level of nuclear reactions.
And there is also another, this is more of a comment, there's a phenomena with earthquakes. You get earthquake lights, which is a glow over the earthquake area. It was for a long time discounted by science, but once it was recorded on a CCTV camera, it was accepted, you know, and they don't quite know from where that comes. You know, and the last big earthquake in Japan, you can actually see it on some TV footage where you have this huge glow over the earthquake area, you know, and there could be similar, you know, cause.
Thanks for the comment.
Any other questions? Okay, give